Okay, so to wrap up this introduction, we're going to introduce this notion called a factorial, and it's going to be used really, really heavily in some of the other counting problems that are going to occur, and some of the really conventional counting problems that occur. So if you go back to the rule of product video, this has already been sort of touched on. So it's this kind of sequence of multiplication where, yeah, we multiply 1 times 2 times 3 all the way up to some certain number n. And so we call that n factorial. So we use a little exclamation mark to denote this because it's like this really exciting part of counting math. In case you're wondering, all this counting stuff is far and away my favorite part of this whole course. So I'm genuinely excited about it, even though I mostly come off as deadpan, but yeah, n factorial. So we're going to see this quite a bit, and we can do a few operations with it to get familiar with it. First, we'll just start by getting our hands dirty. So we'll start with 6 factorial. This is, if we actually just write out that formula, it's going to be 1 times 2 times 3. And we're going to just keep going until we get to all the way up to 6. So count 1 through 6, and it's this product. And you can either multiply this by hand. And if we do that, we should get 720. If you want to use a calculator, there's typically buttons for this. Now, the calculator I have in my hand is a little different than most, but usually you'll find the factorial button as one of those secondary options. It varies as far as what it's going to be hidden behind. So yeah, we're typically going to access this by using that second or that shift button. And then, so yeah, we'd start by punching in the number 6, the second or the shift button. And it's probably like, I don't know what's typically going to be in the base. It depends on your calculator, but usually you'll see this little x factorial as one of those secondary functions. And then you'd hit equals and you'd get your answer. Something to note with a factorial is that your calculator will only take a positive integer input for it. Actually, I shouldn't say positive, non-negative. You can actually plug in 0, that's fine. But you can't plug in negative integers and you can't plug in decimals in your calculator. And in fact, there's continuous formulas that actually replicate this factorial so that you can extend it to the decimals. And it's related to one of the biggest open things in math right now is the Riemann hypothesis. So if you've heard of that before, it actually has a little bit to do with trying to define these factorials, or like a function that has to do with the factorials, and trying to extend it to the negatives and the decimals and also the complex numbers. And it turns out things get really wacky and we don't know how it behaves when we try to do this natural extension. So yeah, you're like touching on one of the biggest problems in math. Okay, 3 factorial. So what we would do here is just do one thing at a time. So 3 factorial and then my factorial. So 3 factorial is going to be 1 times 2 times 3, which is 6 factorial. And we've already figured out 6 factorial from part A, and that should be 720. So that one, you could probably actually just punch that whole thing right in your calculator. Yeah, like you could plug 3 exclamation mark in there and it will give you this answer. If you try the next one in your calculator, you will probably get an error. Yeah, I tried it. So it doesn't work. It is certainly worth noting that. And it doesn't mean that this thing doesn't exist. What is happening though is that your calculator, if you plug this in, what it tries to do is evaluate the 2021 factorial, which is huge. It is absolutely huge. The number of digits of 2021, I can figure that out pretty fast. No, I can't figure that out that fast. But the number of digits is probably something like 3,000. Yeah, it'd be about like a 3,000 digit long number. So your calculator can't store that super large number in it, and so it just gives up. And then 2019 factorial is also going to be this super huge number, but again, your calculator is just going to give up. It doesn't mean that this doesn't exist. It just means we need to look at it differently. So if you look at the numbers, I've got that 2021 factorial over 2019 factorial. Skipping over 2020 as we all wish we could do. Unfortunately, though, it's going to rear its ugly face. So what we're going to do is look at what 2021 factorial would actually mean. So if I actually wrote out 2021 factorial, I'd have 1 times 2 times 3. I'm not going to write out 2021 numbers. So what I'm going to do is put a bunch of dots. And then I know that this thing stops at 2021. So I'm going to have 2019, 2020, 2021, right? And so the dots just mean I do have everything in between, but it's ridiculous to write it all out. And then on the bottom, I'll do sort of the same idea here. And it's going to stop at 2019. So I'll have some of the numbers before it, like 2018 and 2017. And what you can see here with this product is a whole lot of cancellation going on. So if we actually look at this, my 2019s are going to cancel. My 1s cancel, my 2s cancel, my 3s cancel, and then everything in between are all the exact same numbers. So even though I've written a few extra ones along the bottom, that 2018 is in the top. It comes right before the 2019. The 2017 is up there too. All of these things are going to wipe each other out, and all that we're actually left with is the 2020 and the 2021. So there is 2020. It does exist. It's part of this number. But if I actually multiply these out, I get this pretty huge number. About 4 million. So it's very, very large. Factorials will, in general, grow really, really fast. I think, what's the first number? Yeah, I think it's about 70 factorial. It's close to 70 is the first integer that you plug in that your calculator just stops accepting because it's so big. Where, for example, if you go like 2 to the power of 70, that's still an okay number in your calculator. It's like 21 digits long, but 70 factorial is already more than 100 digit long, and so your calculator is just like given up. So these are some of the arithmetic problems that we can do with this. We can also solve an equation or two. Okay, so we can actually solve some equations with these factorials. What we have to do though is use that same principle as I was just talking about with doing some cancellation. So to solve this factorial equation here, what I'm going to do is get started by rewriting this by expanding. So the thing about factorials is there's all sorts of cancellation. And so the top is going to be 1 times 2. I'm going to just start using dots because they are a little easier to separate from the actual math. So 1 times 2 times 3, and I'll do dot, dot, dot. And I always like to write like the last handful here. So we end at n plus 1, and I'll just work my way back to the last few. I definitely need to have the thing on the bottom showing up so I can get my cancellation. And then the bottom is going to look pretty similar. So the bottom stops at n minus 1. So I'm just going to work my way back. Everything should be one less than the one after it. So if that's n minus 1, the one before it's n minus 2 and n minus 3. And then again, we get all this cancellation. Don't want that to cancel out the n as well. So those are going to cancel. These guys are going to cancel. And then we'll get all this cancellation throughout the middle. And then basically just left with those two terms again. Basically, the number of terms you're going to be left with is the difference between the top and the bottom. So yeah, so what I've got is n times n plus 1 equals 42. And so this is a polynomial equation. You might be able to figure it out from looking at the numbers right now, but I will go through and solve it algebraically. So for a polynomial equation, we're going to bring everything to the left and simplify. And so I should have n squared plus n minus 42 is 0. This does factor. N plus 7, n minus 6 is 0. And so I end up getting n is negative 7 and n is 6. But as mentioned, as far as we're concerned, these factorials are not defined over the negatives. And so my answer is just going to be n equals 6. So this reads that 7 factorial divided by 5 factorial is 42. Yeah, so that's about what we can do with the factorials for now. They're going to start showing up in all of the remaining formulas.